John back with you once again, and this is lesson 6 for year 12 physics, and this lesson is looking at the theory behind the conservation of the change in momentum, and these are normally written examples, explanations. So I've given you a couple of model answers to answer some question. So here's one: how do airbags in cars reduce the risk of injury in a collision? So there are certain points that you have to make in order that to show the links you're making and to show critical thinking. So here it is: a moving car has momentum. When the car comes to a stop in a collision, its momentum will reduce to 0. Now the change in momentum remains the same no matter how it comes to a stop. So, however, the injury can be reduced by decreasing the force of impact, because the change in momentum is force multiplied by the time, and increasing the time the passenger in the car comes to a stop will reduce the force. So as airbags will inflate on collision, the airbags serve as a cushion, lengthening the stopping time, thus reducing injury. Okay, here's another example. Here is another point that you need to keep in mind. So whenever there's any collision, each object undergoes the same change in momentum. The momentum lost by one object is gained by the other object. This is because in a collision, each object is in contact with the other for the same amount of time. Each object also exerts an equal but opposite in direction force on the other object. Since delta P is equal to F delta T, their change in momentum is the same. So this is the answer to the question: why does each object have the same change in momentum? And these are the points that need to be made. And I have some problems on this concept, and here are some questions, and these are the answers towards those. This has got lots of parts. So this question here was about two trains or carriages, one going towards the other, and then they move together as one, so they'll have the same common speed. And then you can solve that final answer by dividing those two.